Good morning and good afternoon, everyone. Thank you for joining Snowflake Office Hours. Today we have hc1, the leading cloud-based precision health platform for healthcare organizations looking to increase profitability and deliver high-value care. Today, I'm excited to be joined by Mark Preston, VP of Architecture, and Bill Robinson, Senior Director of Data Engineering. As VP of Architecture at hc1, Mark provides oversight of the technologies and design of all components that make up the hc1 platform. Mark has been with hc1 since 2004 and has 25 years of software development experience. As Senior Director of Data Engineering, Bill leads the team tasked with normalizing, enriching, and aggregating tenant data. Bill has been with hc1 since 2010 and has 15 years of experience integrating with lab information systems and building actionable analytics from their data. Snowflake was engaged with hc1 as they were looking to modernize their data warehouse. And the interesting point here is that they weren't moving from on-prem to the cloud. In fact, they were moving from one cloud solution to another. The key was that they were looking for a solution that would fit into their existing cloud strategy to enable them to make quicker, better, more informed business decisions. My name is Jeannie Liu. I am your moderator for today's event. As you may already know, office hours are designed for attendees to hear directly from customers about how they solve their most critical data problems, but more importantly, get your questions answered. 3 housekeeping items. If you have any tech difficulties, please chat us in the console. 2 is we will hold all questions until the end, but please type them in throughout the duration of the presentation. And finally, the slide deck and recording will be made available upon completion of the webinar. Mark and Bill, we've got a full house here, so let's get started, shall we?
All right, sounds good. My name is Mark Preston. Just a little background on hc1. We're a SaaS healthcare company based in Indianapolis, Indiana. We've got a background in enterprise application integration and started specializing in integrations with lab information systems around 2011. Our customer base is primarily made up of clinical laboratories and health systems, and we've built a platform over the last few years to take in the data that they generate and build solutions using that clinical data to give them additional insights on their business and how well they're caring for their patients.
So hc1.com provides high-value care solutions to healthcare systems and laboratories. The high-value care initiatives aims to improve health, avoid harm, and eliminate wasteful practices. Our solutions fall into 2 subcategories: lab stewardship and precision health. Laboratory stewardship programs are dedicated to improving the ordering, retrieval, and interpretation of appropriate laboratory tests. Precision health is a medical model that proposes the customization of healthcare with medical decisions, treatments, practices, or products being tailored to the individual patient.
So a little bit of background on what our state was prior to migrating to Snowflake. We started out with MySQL as our transactional data store, and that actually was used as our analytics store as well. We use a separate MySQL database to house each tenant's data, mostly to prevent commingling of PHI. As we had tenants that started to outgrow the capabilities from a performance standpoint of MySQL, we started migrating some of their data to Redshift, Amazon's columnar data store, to provide better performance with their analytics. We also introduced an aggregated data store to take multiple tenants' data, combine them at a de-identified state to give trends across tenants. Some of the problems we ran into with this was we quickly ran into limitations in Redshifts from a standpoint of their compute and storage are combined. So in order to have the capacity we needed for storage, we had to keep growing the cluster size, even though the compute we were getting was not very heavily utilized. Another limitation we had with Redshift was concurrency. A lot of the dashboards and visualizations actually take many, many queries to run, and we found that while the queries themselves were fairly quick, the amount of time it took to render a dashboard was fairly long because queries were queuing up.
So in our current state, and a little bit of a future state, this is our desired state, we'll call it. Our transactional data is not moving. That's still staying in MySQL. But we will have an ETL process, and we do have one that moves tenant data into a corresponding Snowflake database. So each tenant still has their own database in Snowflake to be used for analytics. And then we moved our cross-tenant de-identified aggregate data store into a Snowflake database as well. All of the Snowflake databases can share common reference data now, so we're not updating multiple Redshift clusters with duplicate data. And the migration of data from tenant databases to the cross-tenant data store is handled via direct inserts and update queries now. So we just found it to be much more useful having all in Snowflake and not having to move it into S3, out of S3, go into different clusters. So I'll just tell you a little bit about some of our experiences with Snowflake. First, it's just very easy to use. There's not a very steep learning curve with it. The web UI is very simple and intuitive. The documentation is thorough and very clear. For our move of our data store, we plan on spending about a month to transition that from Redshift to Snowflake. That included changing ETL processes, moving the data itself over. But what we quickly realized was features like using the merge feature of Snowflake eliminated some of the delete and inserts that we were doing within Redshift. We also just found the process of ingesting data from S3 and being able to use different sized warehouses to speed that process up versus being kind of stuck with whatever nodes we were using for our production analytics needs in Redshift. We were able to cut that to about 2 weeks to move our entire data store over. When they say things like you can create a data warehouse in minutes, they're not exaggerating. We loaded about 7 billion rows of data in under 25 minutes with just a large warehouse, not even one of their top 10 warehouses. So we were able to move to Snowflake and shave off 2 weeks of time off of that project. And honestly, most of the time was really changing our ETL processes to take advantage of features that Snowflake had that Redshift didn't offer. Another feature that we've enjoyed is the time travel feature, and we can answer any questions you have about that during the question and answer, but for us, part of it is we are often doing matching and fuzzy matching, and we want to check and see how our numbers compare to each other. Previously, we would just store off a backup of each table after we ran matching queries in Redshift. With time travel, we're able to just record what time we did the matching and compare between different points in time of the same table. It made it a little easier for us to do development, for us to test that, and then resetting the data simply rolling back to that time that you want to use. We have had occasions during some of our rapid proof of concept work where somebody may have truncated a table and we realized we really wanted that data, and it's just a matter of reinserting it. It's not restoring from backup or snapshot. So really like that feature. We've definitely enjoyed that all activity is logged. It helps for auditing and profiling queries. It's more of just the things that you desire typically are just enabled out of the box. You're not having to worry about setting that up. You're not worried about performance impact of writing every long query to log. It's just been very intuitive and very useful. And then working with the Snowflake team has been great. From our proof of concept with the Snowflake team, they built out functions that we use for some fuzzy matching that weren't part of the standards. They had those in place for us to test out so we could do comparisons of queries. And spoiler alert, Snowflake won on those tests, hands down, actually, performance-wise. And then it's truly felt like a partnership. We're not, not just one of their clients, but we really do work with them. There's a local rep here in Indianapolis that we meet with, and they do user groups. So that experience has felt like we are working together to solve our problems and not just, waiting our turn for an answer from them. And their responsiveness and support's been fantastic.
So kind of a, wrap up, and I say our outcome so far because it's an ongoing journey, and we'll be continuing to use Snowflake for more and more. But just from the initial conversions that we've done, we're already realizing a 20% cost savings. And I'll say so far because these are existing ETL processes that were designed against how Redshift worked that we've kind of force fit into Snowflake. So it's not even taking advantage of all the optimizations that Snowflake will allow us to. The biggest key there is the ability for the warehouses to auto-suspend. So if we are doing the heaviest processing as a batch, once a day to load new data, you only have to pay for the compute used during that period of time, where in previous state in Redshift, that server was 24/7 burning costs for us. And then the warehouses we use to serve up analytics are actually the extra small size. We found that those are performant for those needs and very low cost. And again, they auto-suspend when there's no activity because it's not very typical that somebody is looking at reports 24/7. It's very sporadic, and those come on automatically when somebody opens up a report and shuts down when there's no activity. So that's really the key to the lowered costs. Some of the other benefits we've had are reduction in time to implement new dashboards. One of the things we have with our customer base is the ability to create custom tables, user-defined fields. They have custom reporting they'll do. So it's very difficult for us to come up with optimized schemas for their use cases. With Snowflake, not needing to define indexes, sort keys, anything like that, and have it perform very, very well right out of the box has really sped up our development process. We don't have to spend a lot of time troubleshooting performance issues, which allows us to just keep building new content. So that's been really, really good. Some of the other things we've had previously would be multiple customers on a shared server. They're different databases, but they're still running on the same server, would have the possibility of impacting each other from a performance standpoint. So if either too many customers are doing something at the same time for what we've provisioned, or somebody just is developing new reports and happens to create a query that spins out for a while, tying up the server, that impacted everybody. With Snowflake, we're able to create different warehouses for different purposes, whether that's a specific high, a customer that has very long-running queries or a high volume of queries, we can partition them off easily, don't have to move their data at all, or even just have different sizes for different purposes has been really beneficial. One of the benefits that we've gotten that we weren't looking for when we first were evaluating was allowing our customers to actually connect to their database at hc1. With this, with a warehouse that they can connect to and have the ability to govern that without impacting other customers, we're comfortable doing that now. So we've got multiple customers that have their own BI tools that they prefer to leverage versus ours, and they can connect directly into their Snowflake database without any issue. Some of our customers have actually liked the experience so much they've asked our experience with Snowflake and have started evaluating it for their own use, which also opens up the door for the Snowflake's capabilities for data sharing. So that would make it so they could actually have their own content with their own data that's in their account joined with the data that's already in hc1 without even copying it. So that's really exciting to explore. We're looking forward to continuing our partnership with Snowflake, and I think that's all we got. I think we're ready for Q&A.
Great, Mark. Thank you, and thank you, Bill. So we do have a steady stream of questions coming in. So you talked about the 20% cost savings over Redshift, and as you mentioned, it's because you don't need to provision large, expensive clusters anymore. You can use Snowflake warehouses to auto-suspend when they're not being used. So let's click into that a little more and look at what the actual migration process was like from Redshift over to Snowflake. And so that's part one of the question. And then the other one was, before Redshift, what database did you use, or what data warehouse did you use?
I can answer that first question. We were extracting from Redshift to S3 directly, and then using the copy feature in Snowflake to copy that in. That was actually, it's fairly easy in Redshift too. I don't want to knock Redshift. It's pretty easy to extract S3 and then import from it. So I think what was impressive was the speed with which we were able to ingest the data by using a larger warehouse in Snowflake. I was pretty shocked by how quick that went. I planned on several days to move over our 12 terabytes of data. It took a day to do that, and I was quite surprised.
As far as even previous to Redshift, I would say we started with the MySQL transactional database. So we didn't actually have a dedicated reporting tier or data warehouse. It was analytics was more or less an extension to our core application initially, and quickly became a key component of it. And we realized quickly that the transactional database really was not optimized for reporting, and that's what prompted us to look for alternatives, the first being Redshift, since we're already in AWS, our whole platform is hosted there. That was a natural starting point. But again, we ran into the limitations of Redshift, so that's why we looked for an additional alternative, and that's how we came to be in Snowflake.
Excellent. Let's shift gears a little bit and let's turn to slide 6. So this question has something to do with matching. So I'm going to try to make the connection here. You talked about time travel feature that has saved you guys multiple times, and you talked about how you can see the numbers comparing to each other and basically getting a comparison between different points in time. So this question specifically is, talk to us a little bit more about that matching. What is the purpose for? How can it be used in other situations?
Sure. Our matching, one of the main things that we do is we have patients that are coming in from all of our different tenants. For the lake, we want to be able to assign a master patient index. So we use Jar-Winkler, which is a fuzzy matching, and it's probability matching on strings. So we use a weighted string matching algorithm to find, two patients from two different tenants that are actually the same person. But we do have to tweak that. We do have to, our weightings, we need to look at those, see how our matching is doing. And one of the things that, we do update that quite frequently. And this has allowed us to make little changes to that and keep running that and basically writing the data into the same place without having to change code. Only thing we're having to do is compare how good was our matching scores on the test that we did at 2 p.m. versus the one we did at 3 p.m. So it allows us, without really changing where we're putting the data or storing a lot of backups of the same table, that we're able to just compare to see what the results were between two different time points instead of multiple tables. That matching that we do with patient, we do it with other things. We do that with the test names, the test panels that are sent across from laboratories. As you can imagine, there's not really a standard, so you get all different flavors of names, and we need to be able to say, this was a complete blood count at tenant A and at tenant B. So we do a lot of the similar type of matching on other data too.
And even within a tenant, we found that a lot of times there's duplication in their data. So they, especially a laboratory, they typically care more about the transaction of an order. For their normal workflow within the laboratory, they don't necessarily need to know that 2 tests were actually for the same patient. They just treat them as 2 transactions. For the provider receiving those results, it is very important for them to know that that's the same patient. So even within one tenant, we do have value where we can provide matching where they don't give a natural key for that. So we'll use the name with the fuzzy matching that detects transposed characters and things like that. Any other demographic information we get on a person, we can use to raise our confidence that that is the same individual.
Great. Thank you for that. These questions are now having to do with your environment. So what kind of ballpark, the volumes of data that you're dealing with? Can you quantify that for the team? And let's start with that. And then the other one was the number of independent warehouses that you would spin up at any given time.
As far as the number of records, I mean, volume, we're adding a little over 1 million test results a day through our transactional databases, and we do push that in within 24 hours to our tenants' data stores and our aggregated data store. Right now, we're at about just a little over 7 billion result records that we have stored across the different, of course, for each individual tenant, and also stored in our aggregated database. There are a lot of other records that are linked to that, but that's the most granular table we have, and just a bit over 7 billion.
As far as the size of or what type of warehouse we have, within our Snowflake account, we have what we would consider 3 different regions: development region, test, and production. So there is some duplication. The non-production ones are smaller size generally, but for production, we have a large warehouse that is primarily used for just loading, and then an auto-scaling warehouse that is actually just set to extra small and scales out to, I'd have to even look to what's the maximum it has scaled to at this point, but that's used to serve any of the analytics, the user-facing stuff. We also have some processing that does just general lookups throughout the day that also hit the extra small cluster. So it's a pretty modest footprint from a warehouse standpoint.
Yeah, that's pretty amazing with 7 billion records, the ability to handle. Let's dig a little deeper. So how are you actually getting all that data into Snowflake? What is the ETL tool or strategy that you're using currently?
The initial data comes in through just HL7 messages. Then we have our own integration engine that puts that into the tenant database. Once we move from there, the ETL process, we're using Pentaho currently. Not really married to Pentaho, specifically, I guess, Pentaho.
Data integration.
Data integrations, right, PDI. We're not married to that. There's obviously we could constantly glue or Lambda jobs. There's a lot of AWS options out there. We were just familiar with Pentaho, and that's what the existing process was set up in. But really, we're doing a lot less in Pentaho per se. It really is just orchestrating all of the work that the actual engine does, the database engine. There's not a lot of T, I guess, in the ETL right now.
Yeah, there's more extract and loads and transformation. And to reiterate, the Pentaho job was the existing job we were using to go from MySQL to Redshift. So it was very minor changes to that existing process to, instead of loading Redshift, now load Snowflake. We do have S3 as a landing zone for that data when we do the extract out of MySQL, and then it's a very easy process to load it then into Snowflake. And the way that Snowflake natively can define a stage to read straight out of that bucket, it just makes it so easy.
Absolutely. And I guess that brings us to this next question here is how much of the data that you're dealing with is real time, and how do you get and prepare real-time dashboarding?
So right now, most of the real-time dashboards are still out of the MySQL side, but because most of those dashboards are focused on very small lengths of time, it's still performant, and that's fine. We do have the ability to do diffs that we can define how frequently it runs to move it into the tenant Snowflake database. Right now, I want to say we're doing a 15-minute differentials for some of the larger tables for clients. But most of the clients are using it still for 1 day in arrears. They're not looking at it as a real-time store. For us, though, that is one of our goals, is to have it near real time so that we can move all analytics over to Snowflake and off of the MySQL side.
Yeah, so I think future state, to get closer to that near real time, we want to take advantage of more of a streaming approach to get the live transactions flowing into Snowflake. That may give us a chance to investigate Snowpipe potentially, so it might be our process as records are persisted in our application, writing copies out to S3, maybe using Kinesis streams or something along those lines, and letting Snowpipe, pick it up from there, and automatically add it to the data warehouse. But that's kind of future contemplation.
Absolutely. And just as a friendly reminder, Snowpipe is Snowflake's continuous data ingestion service. So that's what Mark and Bill were referring to. So let's get into more of the competition that you were looking at. So we talked about how you were moving from Redshift, but what were the couple of things that were just completely unique to Snowflake that really sold you on the product?
During the evaluation, the things that stood out to me were the efficiency of the separation of storage and compute. That was really key. Like I said, when we were in Redshift, those were tied together. We had to size our cluster, and our limiting factor was more our volume of data. So being able to send all of our data into Snowflake, cost was for storage is minimal relative to the compute size. So that really lowers, any reluctance to send more data. The more you send, the better, is our thought. So we didn't want some economic barrier that's telling us not to load data. So that was key. Just the flexibility of the scale of the auto scaling of the warehouses has also been a challenge for us. Like I said, we've been fighting concurrency issues. So having warehouses that can scale automatically on demand, really answered that problem we were facing. So I think those were a couple of the main points during the evaluation.
And for me, with the volumes of data we were working with, we were seeing quite a bit of just long-running queries. We had a density node in Redshift, so it wasn't necessarily that fast to do compute. We needed terabytes of data space. So performance wasn't great. And I think part of it was I'd spent quite a bit of time learning how to optimize Redshift. I was skeptical, to be honest, about the idea of not having to do distribution keys and sort keys with Snowflake. And I was pleasantly wrong to be skeptical, because I don't spend any time anymore worrying about what index or what to, how to partition the data out. It is like magic. I've heard it described that way by other users too, and it's true. I was skeptical, and I was definitely wrong.
That's great. We like to convert skeptics one at a time, so I'm glad you refer to Snowflake as magic. So we have just a couple minutes before we need to close. A couple questions came in that were more of to do with your environment again. So did you set up your dev environment versus a prod versus your test environment? How is your environment set up now?
Sure. For our non-data warehouse, there is complete stacks in AWS separated. Within Snowflake, it's all within one account, but it's just set up with different naming conventions for the different databases and warehouses. We have set up different roles to only allow access to the specific resources that are for a given environment. So there'll be dev-specific roles, test-specific roles, and prod-specific roles. Even within those environments, we have additional roles to limit down to specific databases. So obviously, with healthcare and HIPAA, we want to lock down the data as much as possible to make sure people are not accessing things they shouldn't see. So a given tenant of ours will have a specific role that only grants them access to their database and nothing else. So we do leverage the role security provided by Snowflake very heavily. Even within a database, we'll have multiple schemas with different varied levels of access to even further make that lockdown.
Yeah, that makes sense. So, folks, we are at the 10:30 mark. Mark and Bill, I appreciate you. We all appreciate your time. Thank you so much for this wonderful presentation. For everybody on the line, I know you've brought in a lot of great questions. We're going to have somebody reach out to you directly to answer those questions. So thanks again for your participation, and we hope to see you at the next office hours. Thank you, everyone. Have a great day. Thanks again, Mark and Bill.
Thank you.
Thank you.